With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, welcome to Doubtnut. So in this question we will be talking about combination of resistances. Okay, so we know that there are two kind of combinations. So in first case we will be dealing with series combination, as you can see in the figure of the circuit itself. Okay, this is a series circuit. Okay, so let's say in this series circuit the current is I here. Okay, so by Ohm's law we can say that by applying Kirchhoff's current law, Kirchhoff's voltage law in the whole in this loop here, we can say V minus the voltage drop across this resistance, that is I into R1, minus the voltage drop across this resistance, that is I into R2, minus the voltage drop across the third resistance, that is I into R3, will be 0. Okay, so from here we can say that voltage will be equal to I common into R1 plus R2 plus R3, but we know that the voltage V is equal to IR. Okay, and since current is I in the circuit, so we can say V will be I into R equivalent. Okay, let's say V will be this I into R equivalent. Okay, so from this we can say I into R equivalent will be equal to I into R1 plus R2 plus R3, and from this you can get, therefore the resistance equivalent in case of series circuit is R1 plus R2 plus R3. Okay, for three resistors, and let's say for n different resistances will get R1 plus R2 plus R3 and up to Rn for n different resistances. So basically we got the answer for series combination. Now we'll look for the parallel combination. Okay, we know that in parallel combination the circuit will be like this, as you know. Okay, this will be the circuit. Okay, and the voltage V will appear across all the three resistances, let's say R1, R2 and R3, and this is the case of parallel combination. This is the case of parallel combination. So let's say in R1 the current is I1 here, let's say it as I1. Again in R2 let's say current as I2, and again in R3 let's say current is I3, and let's say in whole circuit let's say the current is I. Okay, so we know that I will be, by Kirchhoff's current law at this junction, applying the Kirchhoff's current law at the junction, we'll get I equal to I1 plus I2 plus I3, that is the incoming current will be equal to the outgoing current, that is I is this I is incoming current, and this I1, I2, I3 is the outgoing current. We know that. Okay, so since I will be the resistance equivalent into, sorry, the I will be voltage upon resistance equivalent. Okay, the I will be the voltage upon resistance equivalent, and I1 will be, since across all the three resistors the voltage appearing is V here, so I1 will be V upon R1. Similarly, I2 will be V upon R2, and I3 will be V upon R3. As you can see here, V will be cancelled from whole equation, and will get 1 upon R equivalent will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, for parallel combinations. Okay, so in a generalized term we can say for n different resistances, therefore we can say for n different resistances 1 upon R equivalent will be 1 upon R1 plus 1 upon R2 plus 1 upon R3, and so on till 1 upon Rn, where n is the Rn is the nth resistance here. Okay, so these are all basic facts about the combination of resistances, guys. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.